Okay, so today I want to talk about this automatic smart plant watering kit from Elecrow, and it's pretty much what the name suggests. So you can use the moisture sensors to measure the moisture of the soil, and based on that you can automatically provide water so the plant will nicely grow. Inside this box is everything that you would need, including this Arduino based driver board. And because the board also includes a small OLED display, in this video I will try to update it with a nicer graphics. Actually, let me jump into the future and show you the final result. I want to show a different looking plant icons based on the soil moisture. So let's open the box and let's get started. Inside the box we have the 4 capacitive moisture sensors which should be put inside a pot into the soil. They include wires, but there are actually much longer wires included in the box as well, so you don't have to use those short ones. Then there is the water pump and 4 valves. They are actually placed inside one unit. This piece should be used to connect the pump with the valves, so the pump goes here and the valves goes here. And for all of those connections there is this long hose, which you can divide based on your needs. Then there is a 12-volt power supply because both the pump and the valves run on 12 volts, the USB cable, and finally the most important piece is this Arduino based board. It's called Crowtail Smart Pump Shield and it's actually packed with features. There is this big power switch, the reset button, the user button, USB port as well as the port for the 12-volt power supply, the 128 by 64 pixel OLED display. This one is not soldered, so you can replace it with your own, perhaps a bigger one if you want. Here is the battery holder because this board also includes the real-time clock module, and finally 5 relays for controlling 5 12-volt devices, being of course the water pump and 4 valves. So let me connect everything together and see if we can see something on the OLED display. And actually all we have to do to get this board up and running is to connect the 12-volt power supply. And right after connecting it, we can see main screen with the 4 flower icons as well as the values from the moisture sensors. But obviously since no sensors are being connected, we are getting some random values. And if the random value is below some threshold, it will trigger the relay. So from time to time you will hear those clicking sounds of those relays. If I press the user button on the right side, it will jump to the next screen where I can see the date and time. But since the battery for the real-time clock module is not there, both the date and the time is also random. Now, as mentioned in the beginning of the video, I want to replace the default graphics with a nicer looking icons. And it should be quite simple because you can download the Arduino sketch used on this board and then of course make some modifications, like for example changing the images. Now when working with OLED displays and graphics, it's nice to have the real-time feedback, and that's the reason why for many of my projects I use the Walkway, which is a free online Arduino emulator, and it supports quite a lot of different Arduino boards, but not this one. I mean, not this chip. If you look close enough, this chip is called Mega32U4, and I believe it's the same chip that's being used in the Arduino Leonardo boards. Again, the Arduino Leonardo is not supported on Walkway, but I think that we can just use the Arduino UNO and it should work for most parts. It should definitely work for drawing the stuff on the OLED display, and that's all that I need. Let's download the INO file from the Elecrow website and paste it in Walkway. Well, let's just, run it, what happens. And you can see that we are missing the UHG library, but there is this button saying install the library, so I'll click it and it will add the library into our libraries. And it also added the RTC library, so I think that we have all the libraries covered because the wire library is a part of the Arduino itself. So let's run it again. And it's running. So the sketch is running, but nothing is being displayed because we don't have the display. So let's actually edit the display. And here you can see that we are using the SSD 1306 128 by 64 pixel resolution display, which is the one that is supported on the Walkway as well. So that's this one. I will edit. And just because there are no special pins defined in this initialization routine, it means that we are using the default I2C pins, which for the Arduino UNO are pins A5, that's the clock, and A4, that's the data. Those pins are also up here, and on the real Arduino board they are oftentimes labeled properly. So I'll connect the ground going to ground, so this ground, and the VCC connected to 5 volts. And then the SCL, the serial clock, should be connected to pin A5, and the SDA, the data, should be connected to pin A4. So let's restart it one more time and see if there is any change. And we indeed see some time and the date displayed on the OLED display, but obviously this is not the correct time and not the correct date, because we don't have the RTC module. Thankfully the Walkway simulation supports the RTC module, so type in RTC and drag in this RTC module, and this module as well uses the I2C connection, so I'll connect it in the very same way, ground going to ground, and then the SDA data going to A4 and SCL clock going to A5. And if I restart it one more time, I should see the correct time and correct date being displayed on the OLED display. But this is quite different from what we have seen on the real Arduino board, because there we've seen those flowers and values, and only when we've pressed the button we have seen this screen with the time and the date. Which of course means that the pin to which the button should be connected is reporting the state which is causing the OLED display to display this screen and not the main screen. So if I look into the code, I can see that the button is set to pin number 12, and if I search for this button in the code, there is this initialization which sets the button as input, and then we read the state of the button, and if the button is high we show the main screen, and if the button is low we show the time and the Elecrow logo. Which means that we have to add the button and connect it in a way that when the button is not being pressed, it should report the high state. So I will connect the pin number 12 to the button, and on the other side, so this will be always connected, I will use the pull-up resistor, so resistor connected to this pin, and then connect it to the high state, so to 5 volts. And let's maybe change the color to red so it's obvious what's going on. So now when the button is not being pressed, the pin number 12 should be reporting the high state because it's connected to 5 volts. But when the button is pressed, we should connect the other pin to ground. So when I press the button, it will be reporting low state. So let's restart the simulation, and we should see the main screen displaying the flowers, which seems to be the case. Obviously those numbers are quite random, but when I press the button, I should see the time and date, and when I release the button, I should go back to the main screen with those flowers. So the OLED display is reporting some strange values, some random values, and that's because it's reading data from the sensors which are not there. But if I look into the code, it seems like that the moisture sensors are connected to pins going from A0 up to A3, and then if I search for this value, we see that we are reading the analog value of those pins. Which also means that we can simulate the different values using the potentiometers. So I'll stop the simulation and add the potentiometer, and I think that this time I will add the slide potentiometer that will kind of resemble the sensor a little bit more, and rotate it using the R tool, and then connect the signal to pin number A0, and of course VCC to 5 volts and ground to ground. And so if I restart the simulation now, I can control the value of the first reading using this slide potentiometer. So you can see it's going down, and if I move it down even more, it goes to 5% all the way to 0%. Let's add 3 more potentiometers so we can simulate the values for all 4 sensors. And with all the potentiometers connected, we can now simulate the values for all 4 individual moisture sensors. So let's move on to the next step, and that is to replacing those icons with different ones. We need to create the graphics, and for that I will be using Photopea, which is a free online graphic editor similar to Photoshop. In here I will create a new image in the size of our display, which is 128 by 64 pixels with the black background, and hit the create button. We need to show 4 different sections on the display, which means that the one section will be sized 32 by 64 pixels. So I will select the selection tool and select the size of 32 by 64 pixels. Then create a new layer and fill it, for example, with some dark gray color. So select the fill with custom color, being some dark gray, hit the OK button, and this is our place for one icon and one readout. And let's actually start with the icon. So I'll start with the path on the bottom, and I will be drawing most of the stuff using the pencil tool, which is hidden behind the brush tool. You have to right click brush tool and select the pencil tool, set the size to be only 1 pixel, then click this button to make the foreground being black and the background being white color, and then switch those. So now I'm drawing with the white color. I will create a new layer, and let's call this layer path, and draw the base, for example like this, and place the individual pixel to continue drawing the outline of the path. And maybe this size should be enough. Now I have 1 pixel which I don't really need, and I can delete it using the eraser tool, which is this one, but I need to switch the mode to pencil tool, and again change the size to only 1 pixel, and then I can delete this pixel. I can also draw lines using the pencil tool, and that is done by placing the first pixel, then pressing the shift key on the keyboard and drawing the last pixel, and this way I will create the top part of the path, so maybe something like this, and of course delete the pixels that I don't need. Actually make this slightly smaller, that will probably look a little bit better. I believe I've deleted some of those pixels to create some kind of highlight look, so I'll do this as well, and this is a nice looking path for our flower. Now later on I will be creating different versions of the flower, and I will most likely hide some stuff behind the path, so it might be a good idea to make this path non-transparent, meaning being filled with black color. For that I will right click the gradient tool and select the paint bucket tool, make sure that the foreground color is set to black, set the tolerance to 0, not anti-aliased but continuous, and then click inside the path. And hopefully you can see it, now the path is being filled with black color. So whatever we draw behind the path could be easily hidden by just moving it behind the path like so. And let's actually draw the stem for the flower by creating a new layer, move it behind the path, let's change the name to stem, select the pencil tool and draw 2 vertical lines, like so. For the next part I will draw 2 leaves, so again create a new layer and call this leaf. And using the pencil tool and maybe zoom in a little bit more, I will create the outline of the leaf, so for example starting with 3 pixels, then 2 pixels, then 1 pixel, and then continue in the same way 2 pixels and 3 pixels. Then I will duplicate the layer by right clicking and select duplicate layer and rotate it by selecting edit, transform, rotate by 180 degrees, position it like this, select both layers with the shift key and then merge those together by selecting layer, merge layers. I can also add some kind of highlight inside and this will be our leaf. I will move it like so and then create one more copy, move it on the left side and then select edit, transform, flip horizontally, move it like so, and we have nice 2 leaves growing from the path. Again, since both the leaves and the stem is drawn behind the path, later on I will be just moving those down to create the different versions of the icon, but for now let's keep it like so and let's create the main part of the flower. I will start with some kind of circle, maybe something like this, and in this case I will also fill it with the black color, so fill the inside with the black color, and I believe I've added some kind of highlight inside, so I will do the same thing in here as well, and then I can continue with the parts around the middle part. So let's draw those petals starting from the bigger ones, again create a new layer, and I might draw shape something like this, and maybe some kind of inner part as well. Now since there will be smaller petals hidden behind this one, I will make this filled as well, so I need to draw the bottom part of the petal and then use the fill tool, make sure it's black color and fill the inside. Then move it on the right spot and create a copy, select edit, transform, rotate by 90 degrees and do this 2 more times to have it also on the bottom and on the left side like so. I will continue with the smaller petals in the corners, again create a new layer, zoom in as much as I can, select the pencil tool, make sure it's white color and then draw some shape, for example like this, and position it so it's touching the big petals like that. I will also add the highlight inside, and this time I don't need to fill it with the black color because those will be on the very bottom, so I'll just create a copy, rotate it by 90 degrees and do this 2 more times to have the complete shape of the flower, like so. And I might move the whole middle piece 1 pixel on top. At this point the flower is complete, but I will move the layers around so the centerpiece will be on the very top. Below the centerpiece will be big petals and below them will be small petals. There's actually one more thing that I've done to this part, and that is to visualize the moisture by creating this like filled layer inside. I will create a smaller layer inside the main part, like so, and then fill it with white color, so this will be like 100% moisture. And then for different versions of the icon, I want to delete part of this layer, so for example this will be 50, this will be 420 and so on and so on, but I don't want to delete part of the layer, so what I will do instead is I will create a copy of this layer, and the bottom one I will call mask. I will like the transparency and fill it with black color, and then for the second layer this will be fill a layer, and I will press Ctrl-Alt-G to make this mask a mask, so now I can move this fill around and it will be only inside this mask layer. So I think that at this point we can use this flower to make a few different versions. I will just create a copy of this 32 by 64 pixel layer, fill it with black color, then select all the layers and group it by pressing the Ctrl-G shortcut. Next step is to create the copy by right clicking and selecting duplicate layer, press the shift key and the arrow key that will move it by 10 pixels, so 10, 20, 30, and then just the right arrow to move it by 1 pixel, so 1, 2. And then we can start making adjustments, so move the fill layer 1 pixel to the bottom, as well as all the petals and the centerpiece, and I will also move the small petals more to the center, so something like this. This could be the second version of the icon. The arrow versions of the icon are done in a very similar way, moving everything more to the bottom and the leaves more to the center. Actually for the variation number 4, I have hidden the small petals. I would like to create even more variations, but there is not enough space on the canvas, so I'll make the canvas slightly bigger by going to Image, Canvas Size, set the anchor to the left side, and make the width to accommodate 11 versions of the 32 pixel icon. And I can just type the equation like this, and if I press the tab key, it will calculate the value for me, so click the OK button, and now we have space for more flowers, so let's continue in the very same way and create more of those. For the next few versions, I'm moving those big petals more to the center until they are invisible, and of course still moving the leaves and adjusting the fill for the path. And once no petals are visible, I've redrawn the centerpiece to be displayed from the side, again using the pencil tool. The very last icon is slightly different, now the stem is bent and there is no fill for the path. In the end, we have 11 versions of the icon, which we will be displaying in the main sketch based on the moisture level. We need to export those icons as individual PNG images, and in Photopea it's quite different from Photoshop because here you can name the layer starting with the -e-, and that will force the layer or the group to be exported. So I will rename the layers with -e- and then use some name, for example flower health, and then some number going from 0 all the way up to 10. Once we have proper names, we can go to File, Export Layers, and click the Export Layers button. That will export the zip file with all the individual PNG images. Next, we will convert those images into the arrays using the Image to CPP website. In here, select all the images, click the Swap checkbox, then click the Generate Code and copy the output. Then jump back into the Work with Simulation and paste the content before the array images, for example in here. So we have the individual images, and we have also this helper array, which is quite useful because then we can use this array to draw those individual images based on the index. So this is what we will be using to draw those images, but I will rename the array to bitmaps flowers. Then just copy the name into the clipboard and find the drawing routine for drawing those flowers. And I think that down here there was a function called draw flowers, which is responsible for drawing the flowers. You can see that based on this moisture 1, 2, 3 and 4 value, if the value is smaller than 30, it will draw the bad flower image, and if it's bigger than 30, it will draw the good flowers image. So I'll just comment everything inside this function, and let's just temporarily paste the array name. So I want to use the same function, UHG draw XBMP function, and for the first image the position will be 0 and 0, but the size of the image is 32 by 64 pixels, and I want to draw the image from this array bitmap flowers, so I'll just paste it in here, and the index should be based on this moisture 1 sensor value, so I'll just use this as an index, but most likely the moisture 1 value has a different range than our index, so I'll remap it using the map function. So I think that the original goes from 0 to 100, I want to remap it between 0 and 10. And just to make sure, I can also use the constraint function, and that will constrain our values between 0 and 10 all the time, so we are not out of index for our image. Let's restart the simulation and see if we can see a different flower image. And that seems to be the case, but at the same time the labels are drawn over the icon, which doesn't look very nice. So first thing, we will just copy this draw XBMP function a few more times for every other image, and we will of course use the moisture 2 value, moisture 3 value and moisture 4 value, and draw those on the X position being 32, 64 and 96. And then let's find the function for drawing those individual labels, which I believe is this function called drawTH. And in a similar way, I will just comment out everything what's inside this function all the way to the bottom. So we are not actually drawing any labels at this time, and restart the simulation. And for some unknown reason, there were some delays between drawing the labels, so now when this is commented out and we are not drawing any labels, everything is much faster, so I can move those sliders and actually show a different image for each individual sensor. So as I drag those sliders, I'm showing different versions of the icon based on the moisture level. But we of course want to draw those labels, we just want to draw them up on top on the display, and looks like that we are setting the font to some predefined font. We can keep the same font, and then we were converting the integer value into some helper buffer, and actually let's create a new helper buffer of the character. Let's call this just buffer, and that can hold for example up to 20 characters. So I'll convert the integer into our buffer using the decimal number, and finally we can print it using the drawString function. Let's set the x value to 0 and y for example to 15, and we will be printing the buffer value. Let's restart the simulation and see if we have one number being displayed for the first sensor reading. And that seems to be the case, but you can see that the number is 256. So it's going from 0 all the way up to 256. But if I look into the old code, it looks like that when the value was bigger than 100, it was just simply kept at 100. So we can use the same constraint function to constrain this value going from 0 only up to 100. And of course we want to draw this centered together with the icon, and for that we need to get the width of the string. Thankfully the UHG library has a function called getStringWidth, which we will use to get the width of the string. So inside our code I will create a new variable and call this stringWidth. And before drawing this, I will calculate it using this UHG function. So stringWidth equals UHG.getStringWidth of our buffer. And then we can center it by drawing it on the x position being the 16 minus half of the string width. So it will be 16 minus string width divided by 2. And maybe we can move it a little bit to the top. So I will decrease the y value to, for example, only 12 or so. So let's restart the simulation one more time. And now the value only goes up to 100 and it's also being centered. So if I show a value smaller than 100, it will be centered, going all the way to just 1 digit, and it still works. So what we can do now is we can just copy this piece of code 3 more times. And we want to get the values from moisture 2, moisture 3 and moisture 4. We just need to update the exposition of the string, so it will be 16 plus 32, which is 48. Here it will be 16 plus 32 plus 32, which is 80. And finally 16 plus 32 plus 32 plus 32, which is 112. So let's restart the simulation one more time and see if we have 4 different readouts, which seems to be the case, and they are all updating and or displayed properly. So our sketch is running as expected. It's time to test it on the real Arduino board. Actually, before I do that, let me move the slider using the arrow keys and show a simple animation of the flower changing its shape and growing as I provide more water. Okay, now we can run it on the real Arduino. I will copy the code into clipboard and start the Arduino IDE. And of course paste the code in here. Now if you have never used the U8G library or the RTC library, we have to install those by going to libraries and then type in U8glib and install this library, and do the same thing with the RTC library. So just copy RTClib, paste it in here and install this RTClib library as well. I have both libraries installed, so I can close it, and then after connecting the Arduino board using the micro USB cable, it's been rightly recognized as the Arduino Leonardo board, so I'll just select this board and hit the upload button to upload it to the Arduino board. A strange thing is that I see some errors, but the sketch was still successfully uploaded. And not only we have those nice looking icons, but now the display also updates much faster because we've removed all the delays when drawing strings. Before I end the video, let me talk about a few things. First of all, I really like this board because it's a great starting point for many projects. You have the button, you have the OLED screen, you have the real-time plug module, and you have 5 different relays. So even if you don't need a watering kit, you can still use it for a project where you have to keep track of time, display something on the OLED display and control some 12-volt devices. And you can buy this board alone for about $30. If you do need a watering kit but maybe something more polished, Elecrow actually has a different product called Grow Cube Plant, where this is much more professional version of this kit, which you can control using your smartphone, and it looks much more polished. And that's pretty much it. That's all for today. If you have any questions, please put those down in the comment section. Thank you very much for watching, and I hope to see you soon. Thanks and bye.